it's your boy the Canologist. Let's do sum of the left leaves. Sum of left leaves. Give the root of a binary tree, return the sum of all left leaves. Okay, so a leaf is a node with no children. Sum of left leaves. Okay, so let's go to the whiteboard. How would I go through this problem? It's like almost 12 a.m. Let's go give that an X, left, left, left. So all the left leaf nodes. So I would just have to find a way to check the parent node. And if it's a dot left, then add it to the sum. So what I'm going to do is I'm going to create a sum variable and call it 0. I'm going to create a helper function. I'm going to pass in the root. And then I'm going to pass in the sum. And then I'm going to return the sum, because that's all we care about. 9 plus 15 is 24, plus 7 is 31. Oh no, we don't add the 7, so 24. It's just sum of all the left leaves. So then I go define my function, helper, takes in a node, and it takes in a takes in a sum. So I have to define my base case. So base case is going to be a leaf node. Node.left equals none and node.right equals none. So this means that it's a leaf node because there's no left and right. Then I want to return. Then I want to traverse. So if left. Oh, if node.left. I want to go helper. So if node.left. Within this if, because I just want to add sums, right? I just want to add sums. I'm going to keep traversing the array as normal. So if I was to traverse this array as normal, all I would do is this helper. So let's just first write the code for helper, right? So helper node.left sum. So add the node here. Then I want to go if node.right helper node.right equals sum. Then I just return. I could go sum equals 0. Just add to sum here. And then create a sum output. And then return the sum at the end. Delete this. And then just do that. Pass in the root. Okay, so now that I define this, I want to define a case where if I get to a position where the next node is a left leaf node, so if left equals none and node right.left equals none. Then I want to go sum plus node.val. So I just add it if it's a leaf node on the left side only. Else I just continue traversing as I normally would. So all I'm doing is basically just traversing as I normally would through a binary tree. And then if I hit a leaf node that's on the left, then is this none on both sides? Left, 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 right. No, this would be left, right. So left dot left. So node dot left is none. Node dot left dot right is none. So let's delete this. Ba, ba, ba. I just want to look at the left leaf node. So this is the node. This is node dot left. So we go down to this node, which is this item here. It's left and right node are things, so I know it's a leaf node. So now I just add the values. So this goes through the traversal till it hits base case. It's going to return, and then it gets to the end. I return that sum value back to here. And then I return that value. So some syntactical bullshit that's not. I can't put expressions in there, so sum plus node val. Okay, let's look at the constraints. If the root is 1, return 0. If root return 0. Okay, so what's wrong with this? Output 0, expected 4. Case 2, 1, 0. Okay, cool. So this works here for the base case. Shouldn't be getting 0. Let's try, maybe it's conflicting names that's affecting it. Let's see, do we change values? No, it stays at 0. So what's going on here? Sum equals 0. Return the total. It's a sum here. That's why. I have helper node. Should be helper node. Wait, let me revert my code first. I just want to see if the logic flaw was because I had this error here. Let's try that. Does it start accumulating value? No. Node left or right, node left or left. There's none, node left equals none, sum equals node. Sum plus node value. I don't know if it's the heat that's drying up my eyes, but I am feeling sleepy. So I'm gonna solve this and then call it. I might do some more, just to make it challenging. Sum is 0, and I keep accumulating it every time there's a leaf node. Then I return the sum. I don't have to return sum, that's why. That's the issue. I just return. I don't have a return value. I could just run it. Oh, that's why. Okay, so let's go back to my old method. Let total equal to 0. Helper root total. Sum manipulates sum. Run through the function. And then return total. It's not accumulating value, that's the thing. Okay. Some of the leaves, some of the left leaves. Self dot root dot left none, root dot right none, return 0. Okay, so that works because it passes that base case. Then we get total equals 0. Helper root, now I create a helper function, takes a node in the sum. If we're at a leaf node, return. Okay. I'm just thinking where could it have gone wrong, and I'm like half sleeping too. This, guys, is why I take energy drinks. I'll take some caffeine. I need like a coffee or something, and I gotta take my allergy pills or whatever the fuck. So that way I don't get itchy eyes, you know what I'm saying? So I have here protein milks, I got energy drinks, I got allergy, whatever the hell. This checks if it's a left leaf. Okay, let's just correct it, because like I want to see where I'm at. I'm at 22 minutes. Okay, so let's just find out the solution. I don't want to waste too much time on it. We'll see where it's gone wrong. I'm gonna pace for a bit before I do the next question. So, chat. I'm getting lost in the syntax somewhere. My code. You guys saw the way I logically look at it, so now let's go through it. Code measures to how you're handling recursive calls, summing up the value specifically. You're passing sum by value in the recursive function, so sum won't persist across recursive calls. If no left and not no left left, check if the child is a leaf. If no left, fix my solution. So I think we just have to return values from the left side. So if not root, boom, sum of left leaves. Okay, that's cool. Tot 0. Using a list to hold the sum so they could be updated inside the helper function. That's a flex. So right now they create a tot 0. I'm like half sleepy. Oh my gosh, I'm sleeping again. Dude, I'm doing these so late that I'm just fucking tired these days. But this is what it takes. This is what it takes. You have to do it when you're tired. Do it tired. You know what I'm saying? So recursively go through left and right. So if not node. So if node equals none, return. If node equals none, return. If node left and node right, so total equals 0. So the reason they turn it into a variable up here is so that you can do expressions on it. 0. Update it allowed since lists are mutable. Okay. So what they did here is they just took this and added it. So all they do is go node.left and if the left child is a leaf node, we check it. Node.left, node.right, so it's going to be helper, node.left. Total plus equals. Total 0 plus equals the sum, the node.val. So they're pretty much doing the exact same thing I'm doing, except the only difference was, the main difference was they just ChatGPT just made the value in here a mutable value. So that way you can add because total is an array with the value 0. So total 0 is the first element in the array, which is 0. And you just add plus equals. Same logic. So now we just have the total is not defined. Okay, so this will be sum. See, it's all the same shit. It's just like a bunch of syntaxy. But as long as you understand this logic here, of like, okay, this is a child node, this is where you want to add, and we ignore this, then we keep traversing, like that's where all the values at. So this is gonna work. No. Sum. Am I missing something? If node left and, node left left none, node left right none, sum 0 node left val. What adjustments were made? I don't see anything. Root total. Okay, so then root total. Let's go through it. If thing, so handle the case where the root is 0. Handle the case where thing is 0. Okay, so I did that. Total equals 0. Okay. Helper root tot, return tot. Oh, return tot 0. That's it. That's the small adjustment. It's all these little tweaks or syntax. Syntax is the killer. Syntax really is the killer. It's not your logic. Sometimes it's just syntax. And we have to drill through these hundreds of times to smooth out our syntax mistakes, because when you get to a coding interview and they put you in on a platform where you can't look up things, or you can't go to another window, or else like they'll stare at you in the camera and shit, right? You'll be ready. I'll be ready, you know what I'm saying? So like, I'm just saying, this is a skill. Like, learning this syntax only comes by doing hundreds and hundreds of questions, because now we get to expose ourselves to places where we do have to do it like this, or we do have to do it another way, we do have to do it in an unconventional way that we're not used to. So let's try submitting it, and boom, beats 99.31% of other solutions. 99%. So our logic here, all they did to modify the logic was turn the input 0 that was passing through my iterable or my recursive function into an array with the value 0. And the reason we did that is because arrays are mutable, and you can do this addition directly on the array element. You see? So if you like this video, please give it a thumbs up, subscribe, comment below. Knologist out.